So we are remaking the 3D maze from Windows with all of the buzzwords. So AI art, augmented reality, mono depth sensing, real-time light estimation, just throw the whole bucket on it. And see whether we'll get an improved model or whether some sort of 90s programmer has outwitted all of the modern words. So it's not lost on me, like, the Kafka-esque-ness of making a maze out of buzzwords. But I just like mazes, so we're just gonna do it anyways. In the original, the maze is procedurally generated, so we should try doing that as well. So how you do that in modern times is you go outside and you pick it off of the GitHub tree. So we're just going to be using this repo to get our procedurally generated maze. I just don't want to spend too much time on the procedural generation. It's a really fun task, though, so if you want to look into it at all, that's something that's a fun thing to make in your own maze. So this particular GitHub gives out basically an array of ones and zeros, and that allows you to create a maze by filling in the ones and leaving the zeros open. So in our case, we're just going to be adding blocks where there is walls, so that's where the ones are, and then when there are zeros, we'll be adding floors and ceilings, and so that'll create a tunnel that will allow you to be in the maze. And so we just, that's basically the extent of the coding aspect. And then for the most part, it's just like a really boilerplate AR scene. So now we have to go back to the texture creation to create the kind of tops and bottoms. And so we're going to use Auto 111 for that. And we're just going to create a few sets of walls. And then I made an extension to create normal maps, and it uses the mono depth information. So that's where mono depth comes from. And so then we have to, once we have an image and a texture, we have to load those into Blender. And so in Blender, we'll just link up the images and the textures. And then we also have to do some UV switching around, which is fairly simple because we're just doing blocks. And once we have all the UVs in place, we'll just load all of the blocks on top of each other. We'll load them up as a singular GLB file, which we can then download in our augmented reality scene and then split apart into the separate blocks in JavaScript. And then we can build those blocks back up with the maze that we created using the ones and zeros. Okay. So I also really wanted to incorporate light estimation because it's really cool. One of the problems that always comes up with light estimation and AR is that AR really likes kind of very standardized lighting, and light estimation only really looks noticeable when it's doing crazy things. So when you have like a flashlight or something, but then if you have a flashlight, then all of a sudden a lot of the AR elements end up being more difficult. So it's kind of an awkward mix-up where, like, if you make a really dark scene that has light estimation, it looks really cool from the light estimation perspective, but from the actual AR perspective, it doesn't look so good. But anyways, the light estimation is I'm always surprised at how good it is. It actually does do a pretty functional job of estimating the direction that you're pointing your flashlight, which is just pretty crazy. So light estimation is a little bit difficult to show on YouTube because you kind of have to see what the camera is seeing and then also see the light, and it's it usually doesn't work out perfectly. So yeah. So there's a few problems that I ran into. The first one is that obviously it's a large enough space that it needs to be really flat. So if it's not flat enough, you just end up walking into the floor because the slope on the real ground is deep enough that you walk into the floor. I'd like to thank this comment. This is what got me started thinking about this. The reason why I think it's kind of Kafka-esque is when you finally escape it, it just returns you to reality.